Guys, day 3, slope-intercept form. So the yellow box here, basically summarizes everything that we've talked about so far to start the class. Okay, look at this, guys. When you're working with lines, a really good strategy is just find that y-intercept and find that slope, and then you're good. Okay, that's probably, like, once we're all done, I'll show you like a couple other forms of the equations, but like this is one that's used in Math 11 and Math 12. Like, this is the go-to version. So if we take a look at this situation about distance versus cost, they're giving you this equation. So identify right away what this 60 represents. What does this 60 represent? Yeah, and a y-intercept is definitely a good answer to that question. But what if it said, like, based on the context, what does that 60 represent? Good, an initial value. You're going to have to pay 60 bucks no matter what before you even drive anywhere. So that's like an initial cost. So in this case, the initial cost we can call just the initial value. That's when d is 0. Or in a lot of cases, when time is 0. So it's when the x component is 0. And then as far as that slope goes, you would need to find a couple perfect points. So I'm thinking like to here, to here. I can see a delta x of 200. And this is from 60 to 100, this looks like about 40. So you can just double check 40 divided by 200. Maybe that gives you about 0.2. It might, I'm not sure. Did that one work? It worked? Okay, I just wasn't sure if the, yeah, rise over run. Yeah, rise over run. So you went from 60 to 100, that's 40, that's the rise. And you went from 0 to 200, that's the run. So rise over run. And that gives us the coefficient that's going to be on the x value, the input. Okay? So for this format, the slope is the coefficient on x. And this is the constant. What do I mean by constant? Like, it doesn't have any x attached to it, so it's always just going to be the constant. It's going to be the same no matter what. It's not going to change. Like this first term, like, it will change depending what x will. Like, whatever x is, that term's going to change. So that's variable. This one here is variable. It will change. I mean, let's be a little bit more clear with my picture. The x is variable, so that whole term will change. And then you'll add b, and you'll get the output y. So again, y is the output, and x is the input. That can be different. So guys, a lot of students do this for some reason. It's really bizarre. They like don't put the y and x in there. Like, you always keep y and x. Y and x are always there when you're doing your equation in general. Okay? You'll see this when we build our... Okay, let's see what this says in the box here. Only use this form to create an equation if the y-intercept is known. This form is very powerful because it gives you information about the line. Basically, it's very powerful because you can get a quick sketch really, really easily. You can get a quick sketch if you know the slope and the y-intercept. And let me explain that to you. So first we'll write the equation. Y equals mx plus b. I kept telling you that you have to keep the y and the x. All you have to replace is the m and the b. So what do I put in place of the m? 3/5. And I got a plus. What's the value for b? So I got a plus a negative 4. What does it mean to plus a negative? Just subtract it, right? So you're going to have y equals 3x over 5 minus 4. Okay? The 3x is in the top. The 5 is in the bottom. And then you have a -4, which is in the top, and you got y, which is in the top. So the only thing that's in the denominator is a 5. So this is a big skill. Like, you'll get multiple choice questions that are this easy. And hopefully you're able to have success on them, because they really are just about identifying. So can you identify, say I gave you this equation, what's the slope? Oh, it's 3/5. What's the y-intercept? Oh, it's -4. Done. And that's it. Okay, like I use this mx plus b in physics 30. I use it all the time. In a really challenging course, I use this equation all the time. Math 31, calculus, really challenging course. I use mx plus b all the time. So we'll end up seeing how powerful that this equation is. Like in science, you'll get a whole bunch of linear relationships. You'll take your data, you'll analyze the data, and then you can relate it to a straight line, which is just this mx plus b formula. And you can have a lot of deep understanding from just a pretty basic formula. So what do I mean you can get a quick sketch? Well, I'll draw a quick grid, plot -4. Where's the next point going to be? Well, I got to go 5 to the right. 1, 2, 3, 4, 5 to the right. And how many up? 1, 2, 3 up. And there's the line, roughly. There's the line. 5 to the right and 3 up, starting at -4. You see how quick that was? I mean, it's just a sketch. It ain't perfect. But you can see how powerful that equation can be. So any questions before we move on? Okay, so let's jump to the next slide. We only have one page to do. No, I paused it. Okay, let's take a look. So we have an equation in the y equals mx plus b form. I would, right underneath it, you guys, to make life easy, I would just jot y equals mx plus b. So clearly, you can see right away that the slope is 1/2. It's the coefficient on top of the x. And clearly, the b value is +3. Which one of those is the initial value? 3. So could I plot that easily? What do I mean by initial value? The x is initial. It's the start of the experiment. The input is 0. So what happens when x is 0? If you could put x equal to 0 here, what would you end up with? Y equals 3. So you can plot that point right here. Now using our slope, could you get the next point? It's 1/2. Rise over run. So which is the 2? The run. Good. So you don't have to plot that, but you do have to go 1 up from there, so you want to plot this one. And that's going to be on the exam. That question. 100%. What do you have to do to finish this question off, though? You need a straight line. If you are too lazy to use your ID card on your exam to draw a straight line, I'm going to dock you marks. If you don't like that, then so be it. You lose marks. Also, if you fail to put on these arrows, I will dock you again. Okay? Because this linear function, this line, is determined by an equation where the equation x could be any real number, and therefore, if you're just multiplying and adding, the y could be any real number. So therefore, the arrows indicate that this line goes on forever. And if you draw a sloppy, squiggly line, you fail the fact that it's linear. So I will dock you for this. It's a very simple question, but you will lose marks if you don't do it properly. Okay. So given an equation, could I graph it? What's the reverse of that? Math is always about that. Good. Now you're given the graph. Can I find the equation? So I would start with this, which will be on your formula sheet. You're not expected to memorize it, but this one I would hope you do memorize. Give you a tip. Find a perfect point. Yeah, I need a couple of them, right? Is there one up top left? And where's the other one? About in the middle there? Right here? If you're given a really nice grid like this, I would just count grid spaces. So how many grid spaces to the right? 2. So the run is 2. How many grid spaces down? 3. And then just have to remember our buddy slope dude. This is nice, negative, nice, negative. So we always try to keep the run positive. So if the run is positive, the rise has to be negative. And then where does this graph intercept the y-axis? Down here at -4. Okay, so then we have it. It's -3/2x minus 4. Yeah. Zach, thanks. So, question 4. This is the more realistic situation that you'll find in the exam. In most exams in math, it's not just about the math. You have to be able to read a problem and then analyze the situation and then apply the math to like model this situation. So this does, students do find this difficult, so we're going to go through it slowly. Student council, you're gonna have a dance, a little dance party. Ticket cost $5, and the cost for the DJ is $300. Okay, apparently it costs $5 to print a ticket. I'm not sure why. Or is it $5 for someone to buy a ticket? Oh, they're asking for a profit. So they don't really give us enough information, so you're going to have to make assumptions. So I would say a ticket, I would say not cost here, I would say a ticket profits $5 for each ticket. Okay. So what happens if somebody bought 1 ticket? How much money comes in? And if you buy 2 tickets? 10. And if you buy 3 tickets? 15. That is this equation, 5x. If x is 0, you get nothing. If you get 1, it's 5. If you get 2, it's 10. That's called proportion. It's proportion. It's based on a proportion. You're just multiplying. 5 multiplied by x, where x could be the number of tickets. Now you have a cost. Is cost sort of the opposite of profit? Profit is like, yes, money coming in. And cost is like money going out. So are you going to add 300 or take away 300? So think about this for a second. You're going to have a party. I mean, you got to probably buy food, rent a hall, you know, all this stuff. There's going to be a lot of costs. But in this example, they're telling you that the only cost is 300 bucks. So you're going to, you know, you got to make money, you got to spend money to make money. You ever hear that? So you're going to drop 300 bucks. So you're already down 300. You're in the negative 300. Now you want X to be sufficiently high enough that you can get higher than 300 and make money. Okay, so how many tickets do you think you have to make or sell to break even? How many tickets do you have to sell to break a profit? Okay? Okay, let's go to answer these questions. Suppose 123 people bought tickets. What's the profit? This is very recipe style math. This is like cookie cutter stuff. 123 people bought tickets. Which one of those is tickets? The X or the Y? Yeah, this is tickets. And then this one is dollars. So that's how you can sort of use the units to support you. So for question B, you would say y equals 5 multiplies the 123, take away 300. You're just given an input. You're given input, and you're asked to find output. This is very common. Sorry I'm boring you, but it's very common. Sorry, I was just doing myself. 315, thank you very much. Now look at question C. Remember how it's always, math is always about the reverse? You do something one way, could you go backwards, do it the other way? What did they give us this time? Are we given the input this time? No, what are we given? The output. And then you have to find the input. So where do I put the output? At Y. Very nice. So 350 equals 5x minus 300. Does that make sense? This is so key to relationships and functions at the Math 10, especially the -2. Like in Math 30-2, I literally teach this over and over throughout most of the topics. Given the input, could you find the output? And vice versa. If you're given the output, can you find the input? And in both situations, you have to do a substitution. For part B, you substitute in X, and it's just a straight calculation, you get Y. But for part C, you have to substitute in for Y, and then do some algebra to find X. So taking a look at this equation, how to solve this bad boy. What do you always want alone? The term involving X. What's the problem with that guy? He's like that friend you don't really want to be around. You got to subtly ask him to leave. Say, you know what, man? It's time for you to go. You're negative 300, so I'm going to do the opposite of you. I'm going to add 300. And then the rules of math say whatever you do to one side of the equation, you got to do to the other. So we got 650 is equal to 5x. Now, you're such a particular person that you don't even want this guy at the party either. You're like, Mr. 5, you got to go, man. You got to go. And right now you're saying 5 times, so I'm going to do the opposite of that. Divide 5. And then you end up with 1x, which is what you want. 650 divided by 5 is 130. And 130 what? Tickets. Very nice. 130 tickets. You guys absolutely have to be able to do these two-step equations, science class and math class, 100%. These will come up all the way up till you're graduated. Okay? What I do find sometimes is students will do the exact same operation. So if they see minus 300, they'll do minus 300 on both sides. So don't do that. You have to do the opposite. That's the key. Now, part D here. Could the profit be 146? How do you know that? Not a multiple of 2. You're so close. Not a multiple of 2, but a multiple of... There you go. Good. So, very good answer. It cannot be... What was it? 146? Since not a multiple of 5. Now, there is a subtraction in there, so you could even just double check this. 146 equals, help me out, 5x take away 300. So then you add 300 on both sides. And then you divide by 5. And then you get a decimal answer. I got 89. 89.2, good. Excellent. And then you would say I can't have 0.2 of a ticket, not a dollar, a ticket. You can have 0.2 of a dollar. Yeah. It's 20 cents. Okay, so here's your homework. You definitely have time to get at least half of it done.